Shall we start? Yeah, I think we can start the session now. So hey everyone, thanks for joining the webinar. So this is the second one that we are doing in the series of DevOps webinars that Physis Cloud is doing. We did one on Loki last time out. So trying to solve the challenges of running a log collecting agent like Loki at scale. This time we are onto another interesting topic, a hot topic probably amongst the community, which is mastering the art of Kubernetes right sizing. So I'm sure you're all intrigued as to what we'll get to learn. So hopefully we can share some of our experiences, right, at Physis Cloud, and probably there is something that you can take back to your work as well. So let me introduce myself and my colleague Vishnu is with me. So I'm Rohit. I'm co-founder at Physis Cloud. So Physis Cloud is a platform engineering product which lets you create your software architecture, and from the architecture we are able to generate automations to manifest your environments, how many ever you want in whatever cloud. We support Azure, GCP, and AWS, right? So I have with me Vishnu, who is a senior infrastructure engineer, uh, and we'll be talking about Kubernetes right-sizing today. Yeah. So I think Vishnu, you can start off uh, with your section.
Yeah, thanks, Rohit. Yeah, hi guys, good evening. Welcome to this webinar. So I'm Vishnu. So I work at Facets as a senior infrastructure engineer, and I've been with Facets for over 2 years right now. And I have over like 5 years of collective experience in DevOps as well as backend engineering. So like pretty much we'll get started with the webinar. So first, let's go over the agenda for the today's talk. So we'll talk about the Kubernetes right sizing problem as well as why it came into existence and what are the root causes that have come up. And we'll be talking about our approach, basically saying that we think this is the right way in order to make a solution regarding the right sizing problem. And we'll be talking about certain processes as well as frameworks that will determine the right sizing part. And we'll be following it with a Q&A session at the last. So feel free to drop any questions in the chat or in the Q&A section, right? We'll be happy to answer your questions anytime. So we'll get started, right? So the problem, right? We all know we are there in this webinar because we know the problem exists and the problem is real, right? So we know that from our statistics right now saying that over 70% of the clusters that are running right now are oversized, right? And the shocking, staggering number is that the average cluster are over provisioned by 60%. So if I say that in a given cluster, say there are 10 nodes running, out of that 4 nodes are only being utilized the right way, and rest 6 are underutilized or even not utilized, and it is burning money, right? So we know the problem right now, and this numbers points us to a right direction, saying that this needs to be fixed, right? So now let's talk about why is this a problem, right? So let's go back, like when people start their cloud journey, they eventually come to Kubernetes, and what they do is they have kind of a template that they followed in VMs and they try to retrofit into Kubernetes, which is a very bad practice in our opinion, saying that there is no direct correlation between each other, right? So what they try to do is they come up with an arbitrary number or even random guesses or even copy paste certain templates from the internet, right? And when they hit say like in some time when they go to production or even say some clusters and some audit happens saying that there's some leakage in costs and there's spike up in costs, then it comes to the developers attention saying that hey, something went wrong, right? So then an audit comes into place and people start bugging the DevOps people, saying that you have to do it and you have to optimize it. Basically, it comes into their responsibility, right? So this is more of a reactive process rather than a continuous process, right? So these are all the issues that are one by one, which will pile up each other. And this is what is happening right now. So what is our approach then? So what we want to do is we want to give a a kind of a process as well as a framework for people to solve this problem. So what we are trying to do is we want say the application owners to right size the clusters. Basically, what we'll do is that there should be some tool that has to give them a golden number from the beginning so that they can start with, and then there needs to be say a democratization or a decentralization of the right sizing responsibility. Like everything should not fall into the DevOps person or the team, because they will be bombarded with all these things, because if they are handling say 10 to 15 projects at the same time, jumping context takes time, right? So we want to democratize that part. And as I told you, since we don't want a reactive process, we want a more continuous process, saying that there should be some feedback loop over there over and over and again, saying that, hey, something is wrong with your cluster, some sizing is wrong with your cluster. So how are we supposed to do that? We can do that by alerts. And we what we can do is we can set up alerts for the oversizing part, so that maybe in their Slack channels or in their processes, saying that the alerts are fired, saying that the sizes are overshot, right? So now how do we get the baseline? So I told you that we want to start with some golden number, right? So we found out there's an excellent tool called VPA. So VPA is Vertical Pod Autoscaler, which is a community driven tool, and it is open source, and it is also supported, like it is managed by the Kubernetes 6 community, right? This is a really good tool, but it is not actively shipped by the managed clusters like AWS, GCP, and Azure. But what we can do is we can install it via Helm chart, and we can get it running in our clusters. So currently, what we do is we run VPA as a recommender mode. So there are two modes, recommender as well as updater. So we are not going with the updater mode because we don't want to say change any configs in runtime on the fly in production or even non-prod environments, which is a very bad practice. What we want to do is we want to take informed decision with metrics, and everybody should be aligned with whatever informed decisions that we are taking by the back metrics, right? So that's why we run VPA in recommender mode. So what VPA does is that, so once you install VPA, VPA creates a CRD, a custom resource definition in Kubernetes. And what you do is you associate that VPA to a deployment, which is your workload, right? So VPA directly associates to your workload. And what VPA recommender will start doing is that it will, based on your workload name, it will start pulling all the metrics that are required. So if I say that I want a history of 15 days to be pulled, VPA would do that. It will go to Prometheus, and it will pull 15 days worth of data and generate some recommendations and start pushing it back to metrics to be stored. So with this, we'll be able to get a continuous feedback of all the metrics that are being generated by the VPA, so that we can feed it to our framework that I talked about. So with this, we'll be jumping onto the framework right now, and Rohit will be taking it up, and he'll be explaining it in detail. So if there are any questions, I am ready to take it up. If not, we can get Rohit to take his part.
Thanks, Vishnu. I'll just present my screen. Yeah. So thanks, Vishnu. So just to recap what we learned from Vishnu's presentation, right? So you VPA or any sort of, there are other proprietary tools also that will give you some sort of a right sizing recommendation, right? So VPA gives you a number as to what your size should ideally be according to an automation, right? You can set up some alerts. So mostly if you set up an alert saying that if the recommended value is less than 10% of their actual sizing, it's usually a very good indicator that you are probably oversized, horribly oversized, right? So we do think that should be there. right? You should set up alerts based on some such metric, and then it should go directly to the developers, and then they have to come about and decide on what the right sizing should be, right? But at this point, we do not recommend directly using the recommendation provided by the VPA or any tool for that matter, right? I know that it's a time for machine learning and AI and everything, but it's something that the developer's intelligence is required here. He needs to analyze and appreciate the data points that are coming in to him, and he needs to use that data and make an informed decision. And I truly believe that it has to come from the application owner. It cannot be completely the responsibility of a secretary. Yeah. So that's it. Um, now, how should the developer's thought process be in terms of deciding how much should be the requests or the limits that I need to set for my workload, right? So again, since we have a wide audience, I'll just recap on what requests and what limits are. So requests is what you say to Kubernetes as to how much CPU or how much memory do you want reserved from a node for your application. So you can't have uh, 4 requests running on a 2-core machine, right? So it's essentially budgeting, right? Uh, what it is used for scheduling. It will be used by Kubernetes to decide what pods can fit into what nodes. And then there is limits. Limits decides when your application is going to get throttled or out of memory killed. So those are the 2 different knobs that you have. So this particular framework that we are suggesting is regardless of whether it is CPU or memory. So we would not be talking specifically about CPU, specifically about memory. We'll be just presenting it for any such controllable metric, resource metric, right? So coming to the framework itself. So first step is data collection, right? So there are some checks and balances that you need to make sure you are following before you go ahead analyzing the data, because you have to make sure that you have collected the data in the right way. Next step is, of course, this coming up with a suggested request and coming up with the suggested limits. And then the framework is not a hard and fast. I mean, it's not a magic one that you can use. You always have to keep improving the framework, and that framework can be improved using some tuning parameters. And these tuning parameters again will change from application to application and also environment to environment, right? So in your non-prods, you would have certain set of tuning parameters, while in your production, of course, you wouldn't have the same set of parameters that you use for right sizing. So coming to the data collection part, yeah. So what you do is, first you need to make sure that you are collecting the data across a long enough time window. So let's say you are on about right sizing the CPU of an application. You would need the CPU utilization history for a long enough window that encompasses all sorts of usage patterns, right? So you might be running an application which has some seasonal tendencies, or let's say on weekends there is a higher traffic, or weekends the traffic might be lower, right? So you need to have a long enough window which captures usually like a 2 weeks plus sort of data. You need to pull it in from whatever is your data. Let's say Prometheus, right? And the sampling interval has to be less than a minute, right? So to make informed decisions in the modern world for a web application running on the cloud, a sampling interval any less than 1 minute is pretty much useless, right? You would have to have very fine resolution data over a large enough time window. Now, that being said, there is one important thing to note here. Oftentimes, it's common practice to use, let's say, a Grafana with Prometheus, or a tool or visualization tool along with Prometheus. But usually, these visualization tools also do some sampling, right? So let's say 2 weeks of 30-second resolution data is like a lot of data points, and of course, it wouldn't load all of that into your browser or things like that. So what it would internally do is do some sort of sampling. Of course, like Grafana provides you what should be the max number of data points to be loaded and things like that. But you have to be aware of that and make sure that no sampling is happening anywhere in this process. Now, coming to the problem statement again, how would you come up with this request? So, of course, I am sure that I'm preaching to everyone about collecting the data. I'm sure that you're all doing it. You're all visualizing it as well. But the problem is that you see a time series data. It's very difficult to make that decision unless you have a set system to analyze it. So what we suggest is that let's boil it down to three scalar metrics, right? So the first is the time-based median of the max across pods, right? So this would help you identify what is my utilization most of the times, right? So this is what is happening. This is what is happening uh, in most of the time for that application. This is the utilization that is occurring, right? And then you would also want to have some sort of a percentile number. So we'll come to how to decide that percentile number as well. So it should be no less than 95th percentile, in my opinion. Uh, so how do you come up with that percentile number is something that we'll learn. So that will let you identify what is the worst of your data points, and then of course the absolute maximum value that has been that you have obtained over the time series, right? So there are these three scalar values are only things that you need to go through this framework. And the visual representation of the time series was only for some sort of validations that, okay, my application is bursty or seasonal, some trends. It would be used only for that. But all the decision making would be based on these three scalar data points. So numbers, three numbers that we have, all the decision making would be done based on this. And you do have the control of whether you are taking risk towards let's say uh, taking a risk on performance for saving some money, or the other way around. You have some tuning parameters with which you can control these as well, right? uh, now I told you, for example, how do you determine what is a percentile number, percentile value that you should consider when doing this analysis. So this is one good place where you can use your time series visualization to understand which percentile number you should be using. So, for example, in this particular case, this is a sample application data that I've loaded up, and I can see that for most of the steady state, the utilization is around this 0.3 mark, which 0.3 mark, which is the median. But then I have this spike. It's a one-off spike, and this is a common pattern that you must have seen. Let's say, for example, an application is starting up, and it does some like I'll just call out Spring Boot applications, right? So when the Spring Boot application starts up, oftentimes you would see a spike in utilization just during the startup, and then it usually settles to a steady behavior after that. So I do not need to plan for this particular spike, right? So I need to eliminate this particular spike when I plan for it, right? So what I can do is what I've done here is I have recorded multiple of these percentile numbers. So I have the 99th percentile, 98th percentile, and the 95th percentile. So let me just mark it out for you. So 95th percentile is the orange line here. The 98th one is the blue line here, and the 99th is the red one here, right? So now visually you can analyze and figure out which is the percentile number that covers most of my major use cases, but eliminates most of the spike. So in this particular case, I would pick the 98th percentile, the 0.4 mark, as the value that eliminates the spikes from. And it's important to understand what a spike is also. A spike is a short-lived increase in utilization, right? It's never an extended period of time. So what is short-lived is also subjective. So it would probably be a minute or 2 minutes, something of that sort in your particular case. So it's, again, something subjective that you need to do. You need to visually analyze your graph, put the percentile, draw the percentile lines out, and then you can come up with what percentile you should consider. So again, based on the patterns of utilization, the percentile number that you would consider for the analysis would change, right? So in this particular case, I would consider the 98th percentile, which is the 0.4 mark. That helps me avoid the considering the spike at all, right? So this is the whole system with which you can identify which percentile number should you track. Now, another thing to appreciate here is that a huge difference between the absolute maximum and the percentile value usually indicates a spike if it is over a small time interval. So this is another indicator, just in case if you would want to reassert your analysis of the graph. you can just take a look at this part. The max and the percentile number that you have picked would have a huge gap indicating that spike. Right. So now let's come to deciding the limits first. So I think the limits you should just have a simple formula of not taking risks at all with the limits. You do not want throttling in any of the applications. You can set it to 110% of your absolute maximum, right? So in this particular case, the absolute maximum has turned out to be 0.9. So you can add a 10% buffer and set the limits to 1, right? So this is the approach that you can take for limits. There are some considerations with limits and requests being too far off. We'll come back to that. But let's move on. So because the request is where the money is at, right? So deciding on request is the most tricky part. Like how do you optimize your cluster's utilization? It's all dependent on deciding the amount of CPU or memory requests that you set for your application. Now, there are multiple ways you can go about it. There are some very easy optimizations that you can do, which have to be eliminated before you go into further advanced optimizations. So this is why we have a track one, which is the most obvious optimization that you need to do, and you should not have any single application which has this sort of a pattern in your cluster, right? So which is I've taken an arbitrary number of 75. This is one of those tuning parameters. We'll get to it. But for now, if there is there is an application whose absolute max has been less than 75% of your request, that means you are oversized. You are horribly oversized. You need to backtrack and set the sizing to 10 with a buffer of 10%. You would set it to 10%, 110% of the max value, right? So this is the most easy optimization, and believe me when I tell you this, that in most of the cases this is the situation that you would see, where people have applications with requests which they never even hit at their maximum, at their peak utilization, right? This would account for almost 20 to 30% of your of the oversizing that is there, that we are seeing across clusters. And this is, you can go back to your clusters and just put a filter on this sort of thing. If max is less than 70% of the request, I'm sure it will spit out a large number of applications. Now, coming to these second, so I can give you an example of this also. Right. So this particular application, so the current request is set at 1 vCPU, which is the dotted line at the top that I've just marked out. The maximum utilization has come around the 0.5 mark. So it is never even touching the one request that has been set to it. So what we would suggest is take the max value, which is 0.5, and set a 10% buffer and set it to 0.55 as the suggested request for this particular application. So this is the easiest optimization that you can do. Now that being said, even when we are setting the request to, let's say, this sort of a line, you are most of the so this particular application has what I call is the seasonal trend, right? So this is a seasonal trend, as in the utilization was steady initially around this 0.15 mark, something around this side, and then for a period of time it had elevated utilization of around half a core or something of that sort, and then it comes back down. And this is a common phenomenon that you see across applications, that there are some certain times of day or certain time of the week where your application will see an increased elevated CPU utilization or memory utilization, and then it drops back to your normal. But what is to note here is that you are, so all of this range, right, where you are provisioning that extra bit of resources, but the application is not actually utilizing it, is actually costing you dear money, right? So you would need to, you can actually optimize this bit as well, which is by, yeah. So now what you need to go back and look at is this particular application's auto scaling configuration correct or not, right? So if I had an optimized SPA which would kick in early enough, right? So in this particular case, so 0.5 is the max it was going to. Now I have an SPA that would kick in around 0.35 to 4, that sort of range. The moment it starts spiking over that particular value, it would scale up and then bring your max to a stabler level, right? Like per pod, if you look at the utilization, it would come down from the previous max value, right? So after the SPA has been optimized to handle the request in a better fashion, you can optimize the spike. So you can reduce the height of this particular bump here, and that way now you can set your post SPA optimization. My max is now 0.4 instead of 0.5, and I can set my suggested request at 0.45. So this is a further optimization that you can do, and this is also a continuous process that you need to do. You always have to be checking with the SPA if your SPA is doing the best job it can to even out any such bumps in your graph, right? So that it can become more steady. Now coming to the second case, which is basically the max is greater than 75% of the request, right? So you're good here. So you're not horribly oversized. You have your max utilization. At least at least during the worst case, it is utilizing more than 75% of your request, right? Now, what is the next thing that you need to analyze? Next thing you need to eliminate is basically spikes. So there are occasional bursts in utilization or spikes in utilization, which is causing your max to be at a higher number than it usually is. Right? You need to identify such cases. So this can be done by tracking the percentile number that we had tracked earlier. So let's take an example. So again, this is the exact same example that we discussed earlier. So in this particular example, we had identified that the percentile number that we would track is the 0.5, 0.4 mark. But the maximum is coming out to be something of the sort of a 0.9. So now, although your maximum is head and shoulders above the 75% line, you can clearly see that there is way too much room. There is way too much resources being allocated to the application, which it is not using most of the time. So, which is why now you would redo the exercise of resetting the request with a 10% buffer, not on the max, instead on the percentile number that you have picked. But here you need to do a visual validation that this is indeed due to bursty sort of traffic. And this is also very common amongst applications. This is the second most common thing amongst application after seasonal, where you would have occasional bursts in traffic, which would spike things up. And again, here too, you need to look at the opportunity of employing an SPA if your application can scale up soon enough to absorb these spikes and bring them down. Right. So now your suggested request is going to be 0.45, which is like with a 10% buffer on the 90th percentile value, which is 0.4. So from the initial value of 1, it is dropping to 0.45, which is a 50% downsize, right? Like a more than 50% downsize. Yeah. So essentially, so this is something that you need to validate from the visual representation, that there are occasional bursts that is bringing your absolute maximum to a higher number than it usually is. Now coming to the third case, this is much rarer, right? So this is the rarest amongst all of the 3 use cases, where max is also greater than 75%, P98 or 99, whatever is the percentile number that you're tracking. That is also above the threshold of 75%. Now, what we need to hold ourselves to is a minimum standard on the median. So basically, during most of the time, your application should be using at least a bare minimum of the request that is allocated to it, right? In this particular case, we are setting it to 10%. So now, what I analyze is my median less than 10% of the request. So this means that your median is super low, but your maxes and the high percentile numbers are in the higher bracket. Right. You would now here again, it's not a clear-cut scenario of you can optimize or you should optimize. It could be, it is a gray area where you could optimize if you are willing to take some amount of risk on performance. Otherwise, just don't do anything. Right. So what we would do is we would try and bring the median to 10% of the request. So for that, we would adjust the request such that the median is 10% of the request. Now, whatever is the request number that we calculated out, we check it, we compare it against the percentile number and see if it is within an acceptable range of that percentile number, right? So for example, right, so in this particular case, the median is 0.07. The max value is 0.8. The 95th percentile is also good, which is 0.7 out of the one value. So these are translating directly to percentages. Now, do I have an opportunity to optimize anything here? Now, as you can see, in this particular pattern, there are repeated spikes or repeated bursts in utilization, which are not being able to be evened out by an SPA. That is the situation, right? So now what I can analyze here is, I have found my median to be 0.07. Now, if I have, what I'm going to try and do is that I'll set my request to such a level such that the median use case is at 10% of the request. So if I have 0.07, it needs to be 10% of 0.7, right? So this would be the suggested line, the 0.7 line. And what I do is I compare it against the percentile number. The percentile number is 0.75. And I can see that it is within the 10% margin of error that I'm ready to risk there, right? So that is basically, I'm taking a slight risk that my node might be stressed if this application goes to its worst case. Is the risk that I'm taking here. So I need to make sure that whatever is the suggested number is coming within an acceptable bound of the percentile number that we are tracking. It might be the case that it does not fall into that bracket, and in that case, do not take the risk. Just go forward, go along. So basically, these are rarer applications where there are unpredictable spikes, and here there is no other option other than over provision for it. So this is the negative example where median is 0.05, the max is 0.95, and per 95th percentile is 0.8. You can't increase your request to, you cannot decrease your request to 0.5, which would be the number which would be required to set the median to be 10% of that value, right? So setting it here is too far away from the percentile number. This is not worth the risk that you're taking, right? Now that you have covered all the three different scenarios, so the most common scenario is where your max itself is not being max itself is well below your request. Second is that the that you're tracking, which eliminates the burst, that is well below the threshold that you have configured. And the third is that you would want to bring the median utilization head and shoulders above a minimum threshold, right? So these are the three different tracks that you can take to come up with a suggested number. So maybe again, so if you have any questions, please do put it up in the Q&A section. I think we will have to revisit these charts once more. For sure, there will be questions. Yeah. So now, focusing on the so once you have come up with a suggested number, suggested request or something like that, you also need to recalibrate your horizontal pod autoscaler configuration if you have something set there, right? So usually people set something on based off CPUs and X percentage of your CPU, then scale out, something of that sort. So now what we need to verify is that so one important thing to note is that HPA works on request, right? So currently it works on request. In the later releases of Kubernetes, there will be an option. There is an option already, I think, in the latest release where you can set it against the limits value. But currently, most of the Kubernetes versions that are actively used, the HPA percentage number, the 50% or 60%, whatever threshold, HPA threshold that you configure, is against the requests that are configured against that application. Utilization versus the request. Now, if you are reducing the request, that number has to be readjusted such that in your median use case, it's not always scaling. That's what we are suggesting here in the mind map. So if the median utilization percentage is greater than the SPA threshold percentage into the new suggested request, right? So let's say, for example, earlier your application had a request of 1, and it used to scale up at 60%, right? If this was your earlier value, that means that the moment a pod starts hitting 0.6 vCPUs of utilization, it starts scaling out, right? Now, now let's say you have dropped it to let's say 0.7. The request has been dropped to 0.7. Then it would scale out at 0.4, right? So sorry, the threshold now is the absolute value of the threshold at which the HPA will trigger a scale up is now 0.4. You have to make sure your median utilization is not more than that. Let's say if your median utilization is 0.45, what would end up happening is that your application purposely tries to scale up, and then you defeat the purpose of doing the whole optimization, right? So this is what we are suggesting here. So if the median is greater than threshold percentage into the new suggested request, then can the threshold you need to re-optimize the HP threshold. If you can do it, then proceed with the suggested request. If not, do nothing. If the median is less than the absolute number you're told and you don't have to worry about anything, you can proceed. And also, if SP is not configured, you don't need to have this consideration at all. So you come up with a suggested number, then you revalidate your SP configuration to make sure that you wouldn't cause your application to infinitely scale up. Now, in this framework, we have used a bunch of numbers. So I had talked about 75%, 10% buffer. None of these things are backed by any sort of data. It's just some sensible defaults. You would have to tune this to your specific use cases, which would be your application nature, your environment requirements, things like that, right? So the maximum threshold that I had set, right? So I was saying that max value has to be at least 75%. If it is below the 75% mark, then you need to kick in. So right, so you need to increase it. I think this is wrong. This is not updated. So I think it needs to be the value. You would increase the value if you are more cost sensitive than performance. So there's a correction here. So this is increase. Then there is this minimum threshold, so which is the third stage optimization that we are doing. What should be the minimum utilization of resources by the application during most of the time? So that we had set to a 10% number. You can increase it if you are more cost sensitive, so that you can make sure that your applications are using most of your resources most of the time. Then there is a performance buffer, which is the 10% extra buffer that we have provided. We can reduce it if you are more cost sensitive than performance sensitive. And then there is the burst risk part, right? So when you were deciding on whether you can set the limits a little lower than your the percentile threshold that you had kept, what is the range within which it should be? That was set to 90%, which is the 0.9 number, the 90%. You can play around with that number, where if you reduce it, you are taking more risk with your performance as opposed to cost. And at the cost of, with the advantage that you can save on cost. Yeah, so this is pretty much the framework that we want to present. I think we are open to questions on this part now. Please do put your questions on Q&A and we'll raise it. Yeah. Right. So could you share the Prometheus query used to generate the graph? Is one of the questions. Yeah, sure. We'll share the query. So we'll share the deck, and probably along with the deck, we'll update the query and share with you. Yeah. Are there any more questions? Yeah, if there are no questions, I think we'll just recap the whole process, right? You should have some sort of automation which will flag when your applications are oversized, right? What we are suggesting is you can use vertical pod autoscaler for it, and your applications will get flagged when they are overpushed. Now, while the vertical pod autoscaler provides you some suggestions as to what should be the suggested request, you still need to do some analysis on your own. And for that, you can use the framework that we had presented. Yeah. Any questions, guys? No questions. That means can be good or it can be bad. Okay. So meanwhile, so we do have a Slack community where we just discuss all sorts of ops and ops queries and questions. And I think those who have not joined yet should join and get in touch with us and have some discussions. Question? Yeah. If you have 10 times burst, if you have 10 times burst occasional traffic, how do you manage the threshold? Right. So Ashok, so as I understand it, your question is that there are the burst is 10 times of your most common uh, your median, let's say. That's what you have. Your question is, right? So in that case, again, so the analysis would come down to it. If it is purely an occasional burst, right? You should not be planning for that extreme spike. You should set your limits sufficiently high, probably not 10 times of the request, but sufficiently high. Probably even 2 times would be okay. But I don't think you should be planning for that occasional spike of 10 times the median utilization, as long as your 90th percentile, 95th percentile, or 98th percentile is closer to your median than to the max. So you should be just planning for what we have shown in the second track. Second. So yeah, so even in this particular case, it was roughly the case, right? So the median was around 0.3, and the maximum spike was around 0.9, which is like 3 times of it. We ended up not planning for it, right? We planned only for 0.45, and we would let the limits handle this part, so that you don't need to set your request according to the spike that happened. This is our take on it. Does that answer your question, Ashok? Right. I think there is one more question as to. I think that's answered, right? Yeah. So, what is the right way to deploy VPA? Yeah. So, VPA deployment is so we generally do not deploy it in the updated mode. We run it only on the recommended mode, and we make sure that whatever is our CI pipeline. Let's say if you have a Helm chart or a customized template, we make sure that along with your deployment template, you also configure the VPA CRD as well. And that's pretty much it. And rest of the things you anyways capture it from Prometheus. You get the recommended value from Prometheus. Yeah. If there are no other questions, I think we're good. Thanks everyone for joining. Yeah, do join our Slack community and we can have further discussions around this. Bye guys.
Thanks, guys. Thank you for joining.